Have you ever wondered what powers the stars that light up the night sky? Our universe is filled with these glowing celestial bodies, each one a furnace of cosmic energy. At the heart of this energy production is a process known as nuclear fusion. Now, don't be daunted by the term. It's actually the simple act of two hydrogen atoms coming together to form a helium atom. But you see, it's not the fusion itself that's the star of the show. It's the colossal amount of energy released during this process. That's the real headliner, the energy that fuels stars and makes them shine so brilliantly. From the smallest red dwarf to our very own sun, every star owes its glow to this fundamental process. So what's the secret behind this cosmic energy production? Let's dive in and find out. To uncover the mystery, we need to understand fusion. Now, fusion isn't your run-of-the-mill process. It's like a high-stakes dance happening under extreme conditions where atoms come together to form a heavier atom. But this isn't a calm waltz. It's more of a fiery tango. The energy that's released during this process is immense. Imagine two hydrogen atoms. They're floating around, minding their own business when suddenly they're thrust together at incredibly high speeds and temperatures. The pressure is so intense that they merge into one, creating a heavier atom, helium. But wait, we're missing something. Where did the extra weight go? Well, it's been transformed into energy. Yes, you heard it right, energy. This is a direct application of our dear friend Einstein's theory of relativity. E equals mc squared, where E is energy, m is mass, and c is the speed of light squared. Now, you might be thinking, this sounds vaguely familiar. And you'd be right. This is the same process that powers the hydrogen bomb. But instead of a controlled, sustained reaction like in the stars, a hydrogen bomb releases all its energy in one violent burst. So in the grand cosmic theater, stars are the main characters, continuously performing a high-energy act. They're like giant hydrogen bombs, constantly exploding. But here's the twist. Instead of blowing apart, they're held together by their own gravity. It's a delicate balance, a dance of cosmic proportions. Each second, stars convert millions of tons of matter into energy, lighting up the universe and making life possible on planets like ours. In essence, stars are like giant hydrogen bombs, continuously exploding but held together by gravity. Now that we know what fusion is, let's focus on how stars use this process. Stars, in their very essence, are fusion factories. They employ this remarkable process to convert hydrogen, the lightest and most abundant element in the universe, into helium, the second lightest. The core of a star is a place of intense conditions where extraordinary temperatures and pressures exist. These conditions are necessary for the fusion process. The core's temperature must reach a staggering 10 million degrees Celsius or 18 million degrees Fahrenheit. Yes, you heard that right, million. At these fiery temperatures, the hydrogen atoms gain so much energy that they begin to move at incredible speeds. But temperature alone isn't enough. The core also needs to be under enormous pressure for fusion to occur. This pressure is created by the sheer weight of the star's outer layers pushing down on the core. It's this intense pressure that forces the high-speed hydrogen atoms close enough together to overcome their natural repulsion. This is due to the fact that hydrogen atoms, like all atomic nuclei, carry a positive charge, and similar charges repel each other. Once these hydrogen atoms get close enough, the strong nuclear force, one of the fundamental forces of nature, takes over. It binds the hydrogen atoms together, creating a helium atom. This process releases a tremendous amount of energy, far more than what was used to bring the atoms together. This energy then radiates outwards from the core, passing through the star's outer layers until it finally escapes into space as light and heat, creating the warmth and brilliance we associate with stars. This continuous cycle of fusion and energy release is what keeps a star shining for billions of years. And that's how a star, like our sun, spends most of its life, converting hydrogen into helium and radiating energy. So we've seen how fusion powers stars. But how does this impact us and the universe we live in? Fusion, it turns out, is much more than a cosmic phenomenon. It's the force that powers our sun, providing the heat and light that make life on Earth possible. It's the process that fuels all stars, sparking their radiant glow and warming the cold vastness of space. But fusion's influence extends beyond illumination and warmth. It's also the celestial forge that creates the heavier elements in the universe. It's in the heart of stars where hydrogen atoms combine to form helium, and in the process release a significant amount of energy. But it doesn't stop there. Under enormous pressure and heat, these helium atoms can further combine to form even heavier elements like carbon and oxygen. And in the explosive death of massive stars, known as supernovae, elements heavier than iron are formed. These materials are then scattered across the universe, eventually forming new stars, planets, and even life itself. Recently, there's been exciting news about fusion's potential as a clean energy source. Scientists at Lawrence Livermore National Laboratory in California have achieved a breakthrough in nuclear fusion research. They've created a nuclear fusion reaction that produced more energy than was put into it. This discovery brings us one step closer to harnessing the power of the stars for our own energy needs. Fusion is considered a clean and almost limitless source of energy, with the potential to generate 4 million times more energy than burning fossil fuels, and without the production of carbon dioxide emissions or long-lived radioactive waste. Fusion, while happening billions of kilometers away in the stars, has a direct and profound impact on our lives. It's not just about understanding the stars. It's about understanding our place in the universe and our future as a species. As we continue to unlock the secrets of stellar fusion, we not only shed light on the workings of the cosmos, but also open up new possibilities for sustainable energy and the future of our planet. The stars have been doing it for billions of years. Can we harness the power of fusion here on Earth? Let's delve into the future of fusion, a topic that's as exciting as it is complex. Fusion, the process that powers our sun and the stars, is being studied by scientists worldwide, all in a bid to develop it as a renewable, clean energy source for our future. Imagine an energy source that's not only plentiful, but also environmentally friendly. That's the promise of fusion. Scientists have had some success with this. At the Lawrence Livermore National Laboratory in California, they've managed to create a nuclear fusion reaction that generated more energy than was put into it. This is a significant milestone, and the first time such a reaction has been observed experimentally. But it's not all smooth sailing. The process currently requires the use of tritium, a rare and radioactive isotope of hydrogen. This presents a challenge for large-scale application. Additionally, the path to making fusion commercially viable is still years away. Despite these hurdles, the potential benefits of fusion are enormous. Fusion is considered a clean and almost limitless source of energy. It has the potential to generate 4 times more energy per kilogram than nuclear fission and nearly 4 million times more energy than burning fossil fuels. Fusion does not produce carbon dioxide emissions or long-lived radioactive waste. It's a game changer for our energy landscape. Investors, including Jeff Bezos, have already invested billions in clean energy startups focused on making fusion commercially viable. The future of fusion is not only a scientific endeavor, but also a business venture. While we may not be there yet, the stars continue to shine, showing us the way to a potential fusion-powered future. The journey towards harnessing the power of the stars is challenging, yet the rewards are immense. If we succeed, we may very well be on the cusp of a new era in energy production, one that's sustainable, clean, and quite literally stellar. So, the next time you look up at the night sky, remember the cosmic dance of fusion happening in those distant stars. This celestial ballet, where hydrogen atoms join forces to become helium, is what powers the stars and the universe. It's the process that fuels the sun, giving us light and warmth. And it doesn't stop there. The fusion happening in stars is also responsible for creating heavier elements, ones that make up our world and even us. The exciting advancements in fusion research bring us closer to harnessing this mighty force. Imagine a world powered by the same energy that illuminates the cosmos, a clean, almost limitless source of power with the potential to revolutionize the way we generate and consume energy. It's a fascinating subject, isn't it? The fusion of atoms in distant stars having such a profound impact on our existence and potentially our future. If you enjoyed this journey through the stars and into the heart of fusion, give this video a like, share it with your friends, and don't forget to leave a comment. Your engagement helps us bring more of such enlightening content. Until next time, keep looking up and keep wondering.